Okay, so today we're going to start with Poisson distribution. You have binomial and you have Poisson, two discrete distributions. So the learning outcomes, you need to know how to define Poisson distribution using the parameters like how you did it for binomial. X with the curly line B and then P, right? This will be different. Now you'll have something else. How to recognize Poisson probability distribution and how to recognize the mean of occurrence, which is lambda. You will have something here called lambda. I will show you later as we move along. Okay, the change of lambda is when the time changes. Poisson distribution is related to time. Okay, so you need to measure the appropriate formula using the correct formula, and you must know how to use your calculator. So today we're going to complete this learning outcome. All right. So to determine if it's proper Poisson, you see if it was binomial, n and p is given to you. But if it's Poisson, you have something scattered in terms of time, or mean number of occurrence in an interval of time. All right, I'll show you the example. See, every time you have any probability question, you're going to define event, right? Like when it came to binomial distribution, is number of whatever. It's still number of, because it's discrete, you can count it. So it's number of faxes received in a given minute. Can you see that? Anything in a given time. Number of deaths due to AIDS in a given year. Number of spellings on a page in the newspaper. There is always a frame. That is what you call the lambda. There is always a frame. The amount of weeds in a square meter of lawn. So it is always in certain frame of time or certain frame of something. Okay, so this is how you describe your Poisson distribution. A binomial, it was this with B, N and P, but Poisson is the lambda. The lambda is given to you in the question. It is the mean, basically. All right, so for Poisson distribution, they only give you one information, which is the mean. All right, so you will use PO and the lambda will be the mean in the question according to the question. If they say in an hour, if your question went in a minute, you need to change it lah. Okay, so this is the formula given to you here. E to the power of negative lambda over lambda to the power of x over x factorial. Okay, you need to see in your calculator where this is. All right, so this is basically a small little guide on how you use your calculator. Probability of x equals, if let's say you want x equals to 2 for a Poisson distribution with a lambda of 5, so you just plug it into the formula. E to the power of negative lambda, e to the power of negative 5. 5 to the power of 2. Can you see lambda to the power of x? So 5 is the lambda to the power of x. X is 2 here. Can you see that? Over 2 factorial. So this is how you put it into your calculator. I want you to try this out first before you try any questions, so you know how to use the calculator. Okay, so for Poisson distribution, your lambda can be decimals. Like example, 1.5 calls per minute, 0.7 can. It can be decimals, no problem. Okay, so the first thing you do as usual, you will define your event, define your distribution, then you must know the formula. Formula given to you in your formula sheet, okay? What does it mean by here? Poisson has no upper limit. You see, like binomial distribution, they've given you n. The n can be 10. That means 10 is your maximum. If I say more than 8, then you do what? Oh, 9, you take the probability of 9 plus 10, isn't it? Here got no upper limit because the number of trials is not given to you in this question. So let's look at this example here, which is also in your manual, so you can do along as you watch this video. A telephone switchboard receives 300 calls in an hour. This part of the question already tells you this must be Poisson because they gave you the number of calls in an hour, something in a frame of time or a frame of anything. Assume that the number of calls arriving in any given minute. This is what you need to highlight. They gave you in an hour, but they want in any given minute. So this is what I need you to highlight as a Poisson distribution. So now what you need to do, they gave you in an hour, they want in a minute, so you need to convert it. So determine the probability that in a randomly chosen minute there will be exactly one call. So first of all, how do we know it's a Poisson distribution? Lambda, number of calls per hour. Do you see that? Now you're going to change it to minute. How to change to minute? This is from semester 1. It's very easy, huh? So you know 60 minutes is 300 calls. 5 minutes, how many calls? Cross multiply and find the answer. I don't think this should be a problem. You write it down as an equation. 60 minutes, why 60 minutes? 1 hour, isn't it? 60 minutes is 300. 5 minutes, how many? Cross multiply, find the answer, okay? So now we're going to work it out. Exactly one call. Again, I'm repeating, Poisson has no upper limit. You have 0, 1, 2, 3 until where you don't know where it ends because the n is not given to you. So you start off with writing your event, number of calls per minute. It's a Poisson distribution with a lambda of 5. Do you see that? Okay, exactly one call. So probability of x equals to 1. This one easy lah. Then you put it into the formula, okay? E negative lambda over lambda to the power. So can you follow here? See, here your lambda is now 5, right? Just now we changed really what? 300 is for an hour. So they want for minute is 5, okay? So basically 60 minutes is to 300. 1 minute, how many calls? I think you can manage this, right? E to the power negative lambda over lambda to the power of x over x factorial. So E negative 5. Why negative 5? You know where's the E in the calculator? Just now we practiced already, right? So E negative 5. So you follow the rules that I've given you there, okay? So E negative 5. Negative 5 is your lambda. 5 to the power of 1. Why 5 to the power of 1? Do you see the x there is, they want 1 ma? So 1 over 1 factorial. Put in the calculator, you will get the answer. 3 or 4 calls. By now you should know how to handle 3 or 4, 5 or 6. It's same like binomial. 3 or 4, you take the probability of x equals to 3 plus the probability of x equals to 4. So you see here now, it's a little bit different here. It's the same thing actually, it's just that here is making your life a little easier. So when you write the formula like this, right, what is a common factor here? E to the power of negative 5 is a common factor, right? Can you see that? E negative 5 is repeating, right? That's why you can factorize it out. You just take it out. You understand? So it's easier for you to put it into a calculator. You don't need to put a whole big formula all together, you know. So E negative 5, then you put everything into the brackets and you get the answer. More than 4 calls. More than 4 calls tells you what? 5, 6, 7 and so on, isn't it? So since there is no upper limit, you got no choice. Okay, you need to take 1 minus 0 to 4. Then only you can find the answer. Understand? Because there is no n. So more than 4 calls, it doesn't mean it's 4 and 5. The lambda is 5, but the n is not 5. So it's not 4 and 5. It is 5, 6, 7 and above. So you have to take 1 minus 0, 1, 2, 3, 4. So you can find 5 and above. Understand? 1 minus 0, 1, 2, 3, 4 there. Can you see the diagram here? So we're going to use this factorization method because I think it's very easy. So 1 minus, you take out the E and the lambda you take out. The rest you leave it in the bracket. Understand? So go along slowly, you should be able to sort this out. All right.